Hey everybody, this is Alex Merced from alexmercedcoder.com with another video on Scala. So in the last video I kind of was talking about the difference between Scala 2 and Scala 3, and you notice I might have had an issue with trying to figure out how am I going to compile the Scala 3 code when my Scala compiler was pointing to Scala 2. So I just wanted to give some more context on that. What happened with me is that I had previously installed Scala using apt, which is the package manager on Ubuntu. So it was like a sudo apt get install Scala. And then I had separately installed Corsair, okay, which is this thing, cs -- version, okay, which can then install sort of all the things for Scala for you. So it installs. So what I didn't realize is that it installs by default Scala 2 and the Scala 2 compiler, and then you can separately tell it to install other things like Scala 3, which I did, but what I didn't tell it to do was install. So it'd be like, I think, cs install Scala 3 compiler. Okay, and that allowed me to install the Scala 3 compiler, so I could separately compile Scala 3 code. So let me actually head over to my Scala folder. Okay, so essentially, when I want to compile Scala 2, I would use Scala C. You can see that points to 2.13. And that was the other thing, is that once I uninstalled the Ubuntu repository version, if I got bumped up from 2.11 to 2.13. And the great thing about 2.13 is that it's like the 2.13 and above are more like transitional versions. Like they're still supporting Scala 2 in the meantime, while people slowly transition to Scala 3. And then if I do Scala 3 compiler, I do version, I have the 3.1 version of the compiler. So I can use this to compile code. So you can see here that I compiled the scratch.js that I made here, which had this hello function. Actually, no, that's the JS. Scratch.scala, which had this my app function, and you can see it got compiled into this. And I bet you're wondering what this tasty file is. The tasty file, that is an intermediary format. So basically the way the newer compiler works, I'm not sure if the older compiler works this way, but the newer versions of Scala 2 and 3 compilers, what they do is they compile to tasty with this intermediate format, and then tasty is then compiled over to sort of a JVM compliant source or whatever source you want. So the idea is that now your Scala gets compiled to this intermediate format, and that intermediate format can then be compiled to whatever target, JS, JVM, binary, whatever. Which reminds me a lot of what this other project is doing, which is mitosis in the JavaScript world, where it compiles to an intermediate format between JavaScript front-end frameworks. So I think that's a cool technique that I'm seeing more and more different language tools use, where instead of just compiling directly from, hey, this is my source code to this, is saying, hey, let's have an intermediate format that compiles to whatever, and then that way not only can you have multiple versions of a language compiled to that intermediate format, you could theoretically have other languages. And then that way, I mean, technically JVM acts this way, so this is kind of like Java bytecode is kind of an intermediary language when you think about it, because it makes it where you don't have to compile to binary. But this is just another layer of that, which is not a bad thing. Abstractions make our life easier. So that's the question. So that will answer. The other way you would compile Scala 3 or Scala 2 code is using SBT, which is basically the build tool for Scala. So that's why it stands for Scala build tool. SBT, I think I have -- version. Anyway, SBT, there we go. Okay. And with that, you can kind of pull down different templates of Scala projects that you can then build from. We'll go into more of that in the future. You could also, I think, use Gradle with Scala. Gradle is another package manager tool in the Java ecosystem that's also used for Java or Groovy, some of the other Java deals. Okay. But what I wanted to do in this video now is talk a little bit more about OOP in Scala. So talk more about setting up classes, because I have to say the way that even though like Scala is like meant to be more of a functional language, I think because of that, because I tend to like functional programming better. The way they do OOP here is a lot more interesting and cool. And the syntax again, especially in 3, where they've really kind of like tried to condense the syntax, really pays off. Okay, so let's go over to here. Actually, I think I want to go down to yeah, start there. Okay, but basically what happens is that Scala uses what's called composition. But you can also technically use inheritance. So a class can either inherit from one class or extend as many traits as you want. And a trait is just basically a collection of functions. So very similar to an interface in Java or Go. While traits are more similar to a trait in Rust. Although, I wonder, can you? Yeah, you can implement multiple traits in Rust. The nice thing about this is that you don't have to create like separate implementation blocks. So like if you ever use Rust, you have to create like, let's say I want to implement 3 traits on one class. I'd have to create 3 implementation blocks where I implement that trait for that class, which can take up a lot of space real quick. Well, here you can do it in a pretty easy way. So first, let's just create some like traits. And another cool feature that is a Scala 3 feature, not necessarily a Scala feature, is the ability to do top-level definitions. So I can be like trait, I can define my traits up here. Before, you'd have to do that in like a package object. So you'd create like a package object where you would define everything, and then you can then use it elsewhere. But there weren't top-level definitions in Scala 2. So that was one of the big sort of new features in Scala 3. So the more I learn about the sort of the differences, the more I think like Scala 3 is really onto something. And again, it's just fresh out the gate. So hopefully this really does increase Scala adoption, because it's pretty neat. Okay, some of the things you can do in this language that I'm not aware of really good ways to express in other languages, or at least just as concise ways. So let's say we were trying to create like a wizard class. So different wizards have different powers. So there might be like fire powers. Okay, so again, that'd be like, we'll say trait fire powers. And then what you can do is you can add what are called either abstract methods or concrete methods. An abstract method would just be like def say name, and then you put a return type, and then that's that. Okay, so I just know that a class that implements the fire powers trait should have a say name function. And then I can do concrete methods where I actually define the method. So I can say def fire, okay, which again is not going to return anything, equals print line fire. So now when I use this function, if I were to implement this trait, unless I decide to override that method, it'll automatically have this version of fire. I don't have to I can give this trait to as many different classes as I want without having to redefine this method. Okay, and then I can do the same thing for like water. Okay, and so we'll just say we'll do a water wizard, and we'll do a wind wizard. So what I can do is I can think of all the different sort of unique pieces of functionality I want and build out traits. So in the case of like, let's say if I were building like an ORM, a trait may be the ability to create, read, update, and delete. So I might create a trait for each one. So and then I can implement all of them on a model class. So a model has all these methods to create, read, update, and delete, but I might be able to want to give a particular other like subclasses or other classes a mixture or a subset of those abilities, and I can easily do so by doing create or by using different traits. So that's pretty cool. And again, the way I'm explaining this is kind of assume that you've done object-oriented programming in some other language before. So generally the way I've been teaching this whole Scala series is assuming that you know at least one other programming language. If you want to see a set of videos where I kind of explain things from like assuming zero previous knowledge, then I'd recommend watching my JavaScript series of videos. That generally is where I'll assume no prior background in programming. So we got wind, water, and then I need to change the name of these functions. So wind, fire. Okay, so I got these classes. And now another cool thing about traits is that traits can now take arguments. I don't think they could in Scala 2, which means I could sit there and say, okay, hey, this trait takes in a name argument. And then now I can say, hey, say name here, I can make say name here concrete, meaning it actually has a definition where it print lines name. Okay, so there we go. So basically each of these, for the exception of water powers, has a mixture of abstract. So again, the definition of a function, but it's not actually defined. So it's not like you can't use it out of the gate. I'd have to define it. And concrete methods, which are ones that actually have a definition to start out with. Okay, so now if I were to create like a wizard class, so I'd say like class wizard, and then I'd write extends. Okay, and then I can extend as many of these as I want. So I can say extends fire powers, wind powers. And then I think I also need to include, yep, I need to include the parameters there. So the cool thing here is I can then just say, hey, wizards have a name, which is a string. So basically you're defining your constructor at the time of defining the class, which is pretty cool. Like it's, you don't have to separately define a constructor, although you can. Fire powers and water powers. So I can say, hey, this particular wizard class, I could make different wizard classes and make a fire wizard, a wind wizard, a water wizard, and then separately make a fire wind wizard, but just to kind of illustrate something, fire powers. And since water powers takes a name argument, I can pass in the name, which will assume that it's one of the properties of wizard, which in this case I have name. So that means this will end up being the name of the wizard. So there's not, well, there is a this keyword. When you're defining your traits, you don't have access to the this keyword, at least not that I'm aware of. So by using these arguments, I can be like, okay, well, at the time of me defining that class, I'll pass the property that I want used in these methods, which is pretty cool. Okay, so essentially here I've defined a wizard class. Okay, and technically I could pretty much just stop there. No, I don't want to do that. Where did I go? Yeah, that's where I was. Okay. Now here's the thing. Do I need to define any additional methods? I could, but here's the thing. Right now, it's kind of workable. So even though I have two abstract definitions of say name, because there's a concrete definition here, it's going to end up, and let me just make this water. Okay, what's going to happen is that it's going to end up using this version. Okay, so a concrete version, lacking any other concrete version, will take priority over the abstract version of the same method. So even though these all have different versions of say name, it ends up just taking prioritizing one of those. Okay, and then theoretically I can add, let's just see here. And I could add more methods, define more properties below. Okay, now since I'm not going to define any additional methods or anything like that, then technically I could just do that. So now over here I can just be like val, and then actually technically this should be var name string. The reason being is that, actually no, I don't need to do that there. And then I think is when I declare it, I will, I know, I think by default it's going to assume var. Okay, so, but I could specify like val or var before name to specify whether I want it to be mutable or immutable. So if I choose to, but I could just do this and it's going to assume that this is a mutable property, since usually when you make objects, the assumption is like mutability of the object. But I will create, a wizard Merlin who equals a wizard. And now back in Scala 2, you had to do like new wizard. So it'd be like new wizard Merlin. I can still technically do this, but now in Scala 3, I can remove the word new and just be like equals wizard Merlin. So it's a lot more, as you notice, the syntax becomes a lot more Python-y. Okay, because again, all of this I could have still done in, well, some of these things I couldn't have done, but this would all have been very curly bracket centered. Okay, but this whole like more tabby, less curly brackets type version of the syntax, I'm allowed to do in Scala 3, but not in Scala 2. Okay, but I'm going to be focusing on the newer syntax because I think it's one easier to learn. And again, going forward, that's probably what people are going to use. And I'm showing you guys so that way, I'm assuming you're a newer Scala developer, so you should probably learn the cutting edge. But again, if I do this, val Merlin wizard, and then I can be like Merlin dot say name, Merlin dot water, although I spelled it with an uppercase. Did I do that for the other ones? I think I did. Merlin dot fire. No, not my last name. Merlin. And I think I do need to put parentheses. This is not Ruby. Merlin dot wind. And let's see how that all works out. Okay, so I will use Scala 3 to just run the program. So I'll say Scala 3. Well, let me just cd into Scratch or cd into Scala 3. And then do Scala 3 Scratch dot Scala. Okay. Now let's take a look at some of these errors. Trait water power's name, but found. So they didn't like that. Although I have seen that traits can take an argument. So let's go find that. Traits. Trait. Let's find, where did I see that mentioned? That traits can take an argument. And then see, this would have been like the older syntax. So you see here, it's the same idea, except you do it in like, you would use curly brackets. Okay, well here, you don't. So, self-type annotations. Where did I see? Program mutable values. Okay, let's search the docs. Traits. Let's see here. Trait arguments Scala 3. Trait parameters. There we go. Okay. I see. I need to like include one of these. Okay. And Scala 3 allows traits to have the parameters, just like classes have parameters. So you see, oh, yep. And then let's see here. Name. Okay. So theoretically, where I made a mistake here is more like I have to include val there. See, extends greeting. So far, that all makes sense. Yeah. So I think that should fix the situation now. So let's try that again. It does not take parameters. When a trait does not take parameters. Okay, so it is complaining that I'm using the parentheses. So do I not use the parentheses? I guess that's the case. If I press does not take parameters. And it still doesn't like that. Oh, I see. I put it in the wrong place. I mean, that's fine there. Let's just get rid of that. What I really want is val name string. That's what I wanted. And let me just compare that to the top there. Yep. Let's try that again. And there we go. Although it still says hello world. What file am I writing this in? Hello world. Same name. Yeah, nowhere should there be hello world here. That's what it came back with. So let's try that again. Scala 3. I think it's still running the package. So let me do this. I'm going to delete this. Delete all these. And there it goes. Okay, so it's the other precompiled stuff that was getting in the way. But yeah, so you see it works. Merlin, so it says name, and notice, so basically what I can do is I can compose a class of traits, and that saves me the time of having to like define a whole bunch of different methods and whatnot. But again, I could define additional methods. I could override the methods if they're abstract and I need to do that. I can override them. So like let's see if I can find a good example of that. Like right here. I would use the keyword override to then override that definition, meaning take the abstract definition and give it a definition, or take one that's concrete and then change it. I can do that. So that's pretty cool. So that's like the basics of just normal object-oriented programming in Scala, but I really like the way traits are implemented. I find this to be like a lot easier way of using traits than in Rust, which is the other main language I've seen this pattern used. And I do love that I can take arguments like this. That's pretty nice. So overall, I like the format of this, and I like the way it looks when it's implemented. So like this was pretty straightforward. And yeah, so I'll leave that at that. And you could define multiple constructors in there. And so you can create different methods of creating the thing and other cool stuff there. Now, what I'm going to do in the next video is talk more about case classes. Case classes are a special type of class which can be used to create more constructs for the sake of like pattern matching and things like that. But hopefully you guys found this interesting. My name is, but again, you can, even in Scala 2, you could create traits and then extend classes on them. But again, I think it's specifically in Scala 3 where we can pass them parameters. Okay. Cool. I'll see y'all later on.